Hello everyone, welcome back to our Generative AI and Agentic AI series. In the previous video, we already learned about what RAG is, how RAG works, and the major components involved in the systems. Now, we'll just connect everything together and understand the complete RAG architecture. So before we'll start with the architecture, we'll just understand about what is the difference between workflow, components and the architecture. Components means individual modules or building blocks of the RAG. So for example, in our kitchen, what parts will exist? Just like as a stove, oven, knife, right? Etc. There are so many things that will exist in the kitchen, but I am just taking these few things over there. And now if we'll talk about the workflow means step by step how that particular flow will execute. For example, when we'll be ordering a food in any of the hotel, what they'll do is they'll take our order. This is the first workflow step, and then they'll go and prepare that food, they'll cook that food, and at the end they'll be serving that food to us. So this is a proper workflow how they'll be working in the hotels. Now after that, if we'll talk about the architecture means we'll be going to explain the system architecture and how modules will connect with each others, or for example how everything is connected with each other. If we'll see how our kitchen system will work and how things are arranged within that kitchen, right, and how they are connected, these are the architecture. So we'll start to understand that architecture. Before understanding the architecture, we should know about this, what is this offline means here. Okay, so does not means that the data only comes from the offline or any local files. It means that preparation or indexing of that data, it is happening before we'll query something or we'll ask some query. Before that, this part will be done. It means what are the preparation, indexings of that data, that is happening before our query. And now the data can still came from online or some sources like as website, APIs or any cloud platforms. So for example, suppose if we have any company document just like as PDF, conference pages, website or DB data, or maybe some other documents will also be there, right? So what will happen is we can run a job which will trigger every day or every night, it will trigger and it will pull all the latest documents from the company, means like PDF, conferences, right? These datas it will pull and it will convert that data into the chunk, and after that it will do the embedding of that data. It will create that embedding and store that data into the DB. Now we have that data in the DB, and this will happen before we'll ask some question to the chat GPT, right? So before that, these process will be done. That's why we'll be calling it as a offline indexing pipeline. Even that our sources are still available online, but still we'll be calling it as offline indexing, because when we'll be calling or when we'll be querying something, that data will always available for us. So that is offline for us. Okay, but some advanced rack system is already there, which they are already supporting that dynamically retrieval, where external data will be fetching at the dynamic time, or we can say at the run time we'll be just fetching that data. Instead we'll rely on any indexing or pre-indexed vector DB, so we'll can fetch that data dynamically. Now we'll look into this RAG architecture. So this is just a naive approach, or we can say basic approach of the RAG systems. So we'll have 4 different structural layers here. 1, 2, 3, 4. These are the 4 different structural layer in the architecture. So first we'll go one by one. So if we'll see here, first layer is data ingestion and indexing. This is the offline layer. So data will go to the data sources. First data will be in the data sources, just like as our documents, PDFs or any web, DB, APIs, anywhere, wherever that data exists, that is the data source for us. And from that data, we'll be doing this chunking and pre-processing. So here that large amount of data will be converted into the smaller chunks. When that chunks will be done, then we'll be going for the embedding models. Embedding model will store that data into the vector DB and it will calculate the semantic meanings here. Okay, and at the end we'll be storing that data to the vector database. So this process we'll be calling it as a offline ingestion offline indexing pipelines, because this preparation will be done before users will be interacting. So this is called as the offline indexing pipeline. So now the next layer is retrieval layer. This is, we called it as a online layer. So what will happen is user will ask some query. Here that user query will go. So this is the user and it asks some query, and after when we'll ask some query, that query will be converting into the embedding again, and when that query will be converting into the embedding, this will be using the same embedding model which will be using in the data ingestion and indexing layer. Same embedding model will be going to use here, and then this query will be encoded here. Now it will go to the retriever, and this retriever will compare that the query embedding, whatever the data we have now, it will compare that data, and with the stored embedding models, means in the vector DB whatever the data is stored, it will take this data and compare all these data. Okay, and after that it will do the semantic search, means in this one it will do the semantic search. So it will retrieve the top k results will be there, so it will retrieve that top k results, and this entire retrieval process happens in real time. Okay, after the user sends a query, so if we'll see here, when we'll send a query, it will convert into the embedding, and after that it will go to the vector DB and retrieve that data. So this process will be happening in the real time. When we'll be asking some query, this process will start, this pipeline will start. That's why we called it as a online pipeline. And then generation phase, here we have to generate some data, right? Because now we have data from the vector DB and the query from the user. So now we have to generate some response. So first, here we have prompt augmentation. So whatever the data it came from the vector DB, top k relevant chunks, and the context, means the whatever the user asks, that question will be augmenting in the prompt augmentation part, and then it will go to the LLM. So LLM will generate the final response using both the combined query and the retrieved context here, and it will generate the response, and then it will send to the user. Then user will get that response, and at the end we'll have maintenance phase. Why we are needed? Because we want our DB will be up to date. If we'll not update it, it means it's same as LLM, that is also not getting updated. But here we have to update our DB, that's why we needed this maintenance option, and this is optional as well. We do not need to do this every day or every time, it depends on our requirement. So we have to update this document, and or we have to do the reindexing here. So whenever that some new data will be coming, or existing data needs to be changed, or we have to generate some new content, at that point of time we are just doing the updation part, and we'll again it will do the embedding and other process, like as data sources we'll have, then chunking and processing, embedding model, this will happen in background, and it will generate and update our vector DB. So this RAG architecture consists of offline indexing pipeline for preparing the searchable knowledge base. So we'll have searchable knowledge base now, and online retrieval pipeline, what this will do is, this will go and fetch the relevant context from the DB, and then that data will be shared to the LLM layer, means this generation layer. In this generation layer, LLM will process that query and context data, or we can say the user's query and the vector DB top k suggestions or top k relevant chunks. According to that, it will just perform analysis, and after that it will produce the responses to us. So we understood how these components are getting connected with each other and making this as a architecture. Now we'll just see the detailed version of this architecture. So here if we can see what all the things within the data source. There are many more things, but there are few which I highlighted here. Okay, so this is the data sources, chunking and preparation, then embedding models will be there, just like as text to vector mapping, contextual spaces, symmetric vectors will be done here, then vector db. And from here this retrieval will access their indexes and get the data from the vector db. And if user will ask some questions, they'll submit their query in the natural language, in our normal English languages or any other languages we can ask it, right? Then that user's query will have input text, and this will reformulate that data or the query which we asked, and then query encoder which will use the same model like here, and it will generate the embedding from that query. And then retrieval will retrieve all the data from the vector db, maybe top k context it will retrieve, and that data will be going to the generation layer, and it will read the context chunk and formulate that answer, and then it will be giving us the responses or grounded output will be there. And then user can see that data, or they can verify or validate that data as well. So if we'll see here for the one component, that is top k context, it has some raw extracts and clean passes or filter and rank. So when we'll be searching some website, for suppose if we'll be searching what is java, we'll be getting 10 or 15 websites, right? In some order we'll be getting it, right? So what is the most relevant will be there, we'll be getting these websites for us. So same way it will just fetch what are the user queries there. According to that query, what are all the most relevant documents will be stored, or chunking will be stored in that vector db, will fetch all that top key context here. And now if we'll see the summary here, so offline ingestion, what it will do is it will just prepare some knowledge here. This is a knowledge pipeline, it will just prepare some knowledge, and it will store in the vector db, and it will be doing this job in the background or before the users will query something. And then online retrieval means this is the real time vector. This search will be happening or will be pulling all these data when will be active, right? Or will be in online mode. At that point of time it will be retrieving all the data from the db, vector db as well. Then generation, this is the static llm synthesizes, and this will do a grounded response, and we'll get that response from the llm. What are the information we'll be getting from the vector db and from our query, according to that llm will generate that response. And this maintenance loop is, this is a asynchronous pipeline. This will refresh the indexes. Okay, this will be going for the indexes, and every time when it will be updating some document, it should reprocess everything, means it will go for the chunking, extraction and embedding. That reprocessing will happen here. Okay, so this is the in-depth architecture of the RAG. So okay, we know what RAG is and what their architecture is, but what are the challenges we are facing for that RAG? So first thing is data reliability. Here what we are doing is we have to update or maintain our vector db. So if we have some outdated or incorrect information that we missed to update that db, at that point of time in our knowledge base we have some wrong information or wrong data sets. So at that point we'll get the inaccurate data from our db, and llm will also generate the inaccurate responses. After that we have latency issue. So latency issue means when we'll be retrieving that data, then that ranking process will work. There is a ranking process, it will work over there, and RAG will search the most relevant data which is related to our query. So from that whatever the sources is available, according to that it will go and perform the ranking process. Suppose if any of the resources will contain some API or some another DB calls, then it will go and call that APIs and get the data, and then it will, or maybe it will go for the DB and it will fetch all that DB data. So then ranking algorithm will be running for this, right? So till the time it will not get that data from the API or DB, it will not rank that particular chunk or data. It will just wait for that to complete. When it will be completing, after that it will be going to give us that document or not. It depends on the data whatever it will retrieve. Okay, so all this process may take some more time, and this will delay the responses. After that, we have managing unstructured data issue. So we'll be converting that unstructured data into the structured data. So if data will be not cleaned, if we'll be storing some data in DB and that data will be not cleaned or not in a formatted in a proper manner, so we'll get the inconsistent data. These are the issues we can, or challenges we'll have when we'll be updating the RAG. So we have to be make sure that these things will be performed correctly, and we'll be going to update our DB every time whenever we have new data. And in the next video, we'll be going to learn how we can implement this RAG concept.